things first, you need to remember that with maths, we always follow rules. As long as you're not violating any maths rule, you're going to get to the correct answer. If I were to give 6 different mathematicians to answer this question, they might use different methods, but they're going to get to the same answer. But what they'll have in common, even though they'll be using different methods or like different methods, they do not break any maths rule. That's the most important thing. Okay, we read the opening statement, we read it to understand. It says, given the geometric series, you already know that the ratio is constant. Okay, this is a geometric series x plus 90 plus 91. Fair. Calculate the value of x. So, how is it that what are you gonna do to find the value of x? What approach are you gonna take? You're gonna use the properties of a geometric series. That's the information you have. You have no other information that this is a geometric series. What do you know about it? The ratio is constant. So you're gonna go. You know that 90 divided by x, ne? 90 divided by x gives us a ratio, the ratio, right? And at the same time, 81 divided by 90. Next number divided by the previous also equals x. You guys see that? Sorry, not x, but the ratio. They all equal to the ratio. Do you guys see that? That is T2 over T1 is equal to, this is what I've written there, equal to T3 over T2. They both equal to ratio. That's what it is. So that's what we're going to use there. Are we all happy with that first line? Thumbs up. I just want to check if everybody's happy before I proceed to the next. Shaylee's good. Kanya's good. That's proper. Lebogang machine is good. Sharp. So this is what it is. They're both equal to R. So here we're just gonna now solve for x. We cross multiply. You guys remember that mathematicians said that whenever you come across this sort of scenario where a fraction equals to a fraction, you're allowed to cross multiply. So I'm gonna go 90 times 90 gives me 8,100. X times 81 gives me 81x. Okay, remember that I am looking for x, not 81x. So I'm gonna divide this by 81 so that they can cancel what I do on one side. I also do on the other. So therefore x equal to 100. You guys get 100 as well? Oh, my calculations are wrong. Proper stuff, ne? No. Let's see. Yes, 100. Who got the answer of 100? One, two, three, 4, 5, 6. God is great. For the wisdom He's given you and the IQ that you didn't know about. You have a very high IQ, but you didn't know because why? You didn't have the right math education at primary level or early high school. So that's why you think that you're not smart, but you are very smart. Show that the sum of the first n terms is Sn equals 1000 open bracket 1 minus 0.9 in bracket squared close bracket. So you're showing that the sum to n terms. You guys remember under like your geometric sequence. Just an example. This is a geometric sequence in which we multiply 3 to get the next number. Okay. You guys remember when they say find Tn, find the general term or the nth term, you'd go Tn equals AR n to the power n minus 1, and then your A is the 2, your R is the 3, n minus 1. This would be your Tn, the general term, the nth term. Now here, basically they're asking for the nth term, but in the context of sums, right? So now you know that you have two formulae for the sum. You've got this one, which you apply when r is less than 1, and this one, which you apply, greater than 1, which you apply when r is less than 1. Now, since our r, or rather we need to find out like what our r is, right? So that we know which one we choose, this or that, okay? So how are we going to find that out? We know the first term is 100, the second term is 90, the third term is 81, based on the 100 we got there. What is our r? R is this divided by this. R is 90 over 100, which is 0.9. 0.9 is a number that is less than 1, right? So therefore, we use the second formula, right? And another thing you should realize is that look at the form of this is 1 minus something something. Even this one, you see, you've got 1 minus something something. You see, so chances are you can't use this one because it's got like what do you call it? It's got an r, like something to the power n at the beginning instead of at the end. So this is the one that you're gonna use. It makes more sense when you look at both the r calculation and how it looks like. So that's why we're gonna use that one. So we're gonna go Sn equals a 1 minus r to the power n, like that. Then we substitute. Our a is the first term, which is 100. We already established that. 1 minus r is 9 over 10. Rather put it as a decimal because it's easy for you to put into a calculator or work with it. So it's 0.9 again, like that. Now you see this bit here looks like that bit. See, so you know that you're going in the right direction. R is 0.9. Let's simplify. We have 1,000, not 1,000, but 100. 1 minus 0.9 n. Please do not say 1 minus 0.9 and get 0.1 to the power n. No, 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 no. This power n affects only the 0.9, not the 1. Don't do that, please. Over, this gives us 0.1, right? And then you go back and check. Am I getting closer to the destination? You look at this. You see I've got 1 minus 0.9 to the power n. I've got that there. And then what do I need to have outside? The 1,000. So that means this 2 must give you 1,000 somehow. You see, because everything else is the same. Now, you guys know that, just an example, 2 times 3 over, okay, 4 times 3 over 2, you can also write it as 4 over 2 times 3. Are you guys happy with that? All of you, thumbs up if you're happy. All right. Okay. 4 times 3 over 2. You're allowed to sort of like put this 2 with the 3 or the 4. You could write it like this, or you could write it like this. Now, if you punch this into your calculator, you still get the same answer. Bonso, are you happy? Proper stuff. You want to put it mathematically? A B over C is the same as A over C times B, or A times B over C. Same thing. Sharp. So we're going to apply that here. This is our A, this is our C. So we're going to go 100 divided by 0.1 times 1 minus 0.9 to the power n. 100 divided by 0.1 is 1,000. Delicious. Then it gives us that answer over there, what they were looking for. Easy peasy lemon squeezy. As hence. The next question, hence or otherwise, calculate the sum to infinity. Hence means use what you already have to get the answer. Hence or otherwise means use some other means. All right? But hence or otherwise, calculate the sum to infinity. Now, there's something that you need to know as a math student that like you just need to know. I didn't know it until I was at varsity. Yeah, did I? Yes. Ish. When I saw it, I was like, ish, what did they teach us in high school, bro? And I was like, ish, these people are killing us. So whenever you have, I'll show you now. Whenever you have an improper fraction, like an improper fraction, no, not an improper, but a proper fraction, sorry. A proper fraction where you've got a smaller number and then on the denominator you have a bigger number like this. Whenever you have something like this, could be 1 over 7, whatever, ne? Whenever you have something like this, ne? And then like you have an improper number, ne? Sorry, a proper number, sorry. Proper fraction, what am I saying? Whenever you have a proper fraction, sorry about that, where you've got where the numerator is smaller than the denominator. Small, big. Whatever it is, 1 over 7, 7 over 8, 2 over 8, whatever it is, small number divided by a bigger number. Ne? Whenever you have like a proper fraction and then it's got a like it's in brackets and it's got a like a power there. Ne? The higher this thing becomes, the closer the value gets to 0. Let's test it. Let's test it here. Ne? Can you put 20 there and tell me what answer you guys get? You get something like this. I'll show you. 1 over something something thousand or a million something whatever it is. You get something like this as a exponential whatnot. In exponential form, you get something like this, which is 0.1, 2, 3, 4, 5, 6, 7. 7. Okay, this is a very small number. Let's go. It's going to be 0 0.00 0.00001, 2, 3, 4, 5, 6, 9, 5, 3. Ne? This is a number. 1, 2, 3, 4, 5, 6, 7. Yes. As a decimal, it's this. Ne? You guys are getting it like this. You can switch your mode so that it gives you a decimal. Ne? So the higher this thing becomes, the closer it gets to 0. It's going to get to a point where it will converge to 0. Can you put 1,000 here for me? Put 1,000. 0. Ne? Put 5,000. What do you get? You still get a 0, ne? So now my chat is that whenever you have a proper fraction, like smaller numerator, bigger denominator, and then in brackets to the power something, ne? The higher this thing becomes, it will eventually like converge to 0, ne? So another way to put it is to say if you have 0 comma something something, ne? Not 1.2 point 0 comma anything, 0 comma anything. That's a proper fraction. That's an proper fraction. 0 comma something something is a proper fraction. Eh? Could be like this or like that, 0 comma something. Just know that if you put to the power infinity a very high number, it's going to get to a point where it's 0, 0 always. Ne? So now, this question says hence or otherwise calculate the sum to infinity. You've got this thing over here, this thing. So what you can do this, since this is a proper fraction, right? You could do this sum to infinity, substitute infinity there, equal to 1,000. That's you using the hence part. 1,000 minus 0.9. You put an infinity. Ne? You know that this like a 0 comma something or like a proper fraction to the power infinity is 0. Then your answer will be 1,000. Do you see? This will be 1 minus 0, which is 1, which is 1,000. Right? That's the hence part. The otherwise part, then you'll use this, the normal sum to infinity formula. Your first term is 100 over 1 minus your r is 1 over. What is our r again? 1 over 0.9, eh? 0.9. Calculate this and tell me what you get. What do you get? Let's talk. It's 1,000, yeah? You get 1,000. Proper stuff. It's 1,000, mate.